In this video, we are going to draw the xt, vt, and at graph with some slightly different instructions. First, the object starts at the positive side of the origin and is going to move at a constant speed until it passes through the origin and reach at somewhere same distance as the beginning. So let's say the object starts at a distance a from the origin and it should be at the positive side. Then it should end at the same distance from the origin, but at the negative side. So it will go from a to minus a, from t equals 0 to equals t1. Now, we can draw some dotted line to help us guide the line that it should arrive. And let's draw some vertical lines to synchronize the time throughout these three graphs. All the way down. It should be long enough. Good. So because the object is moving with a constant velocity, so it should be a straight line in the position graph, and it will be going downward like this. Now, because the position is going from positive to negative, we know the speed is non-zero and the velocity should be negative. That's why the position would decrease its value. So we know the velocity will have a negative value, and it remains the same during this period. So it's going to be a horizontal straight line from 0 to t1. We can also deduce the value of the velocity because the total distance it traveled is 2a, and it spent a time t1. So the speed is 2a divided by t1, but the direction is going downward, so the velocity is negative. Because the velocity is not changing in this period, the acceleration will be 0. Therefore, it's going to be horizontal and lies on the x-axis. Good. So let's move on to part 2. At time t1, the object slows down with a constant rate until it stops. So we know that it's going to change the velocity with a constant rate until it reaches 0. Let's say it's at here, t2, and then the velocity go from non-zero to 0. When the velocity is changing, the xt graph will not have a straight line, but a curve. We see that the object should stop at a distance 3 times as far from the origin as it was at time t1. So it's going to stop at 1, 2, and 3a. So it's going to stop at x equals minus 3a. And at this time, the object is not going to have any velocity. So we know that the xt graph should look kind of flat when it reaches time t2. So when you reach t2, the curve should look somewhere like this, but just at the beginning of t1, the speed shouldn't change much, so it should still have the same slope. So it's going to look something like a curve curving upward. Let me draw it more carefully. Oops, never mind. So it's going to be a curve that looks like this, which reaches 0 velocity when t equals t2. Because the velocity is changing, now the system has a non-zero acceleration. The velocity is changing in a constant rate, so acceleration will be a constant value. It will stay at a constant value. And it takes some time for the speed to go from the velocity to go from negative to 0. So we know the velocity is increasing in a positive direction, which gives us a positive acceleration. So it's going to be a horizontal straight line over here. So this is how the acceleration should look like. We can also deduce the value of this acceleration. The velocity increased from negative to 0. So the change is 2a divided by t1. And it takes a time t2 minus t1 to make this change. So there will be t2 minus t1 in the denominator. And this will be the value of this acceleration. Now, let's move on to part 3. The object remains at rest for a short period of time. So the position of this object will stay the same during this time period. And the speed will then, of course, be 0 because it's not moving. And the velocity maintains at 0, which gives us a 0 acceleration. So the acceleration becomes 0 again between t2 and t3. At the end, the object speeds up with a constant rate to a speed half of its original speed. So the speed will go up to a speed that is only half of its original speed, and it will reach the origin, or it will cross the origin. So we know the velocity should be positive. That's how the object is going to move closer to the origin and increase the value of x. So the speed will reach this point at t equals t4. Let's draw some dotted line to guide us. And it's going to increase its velocity with a constant rate, so it's going to be a straight line again. At the same time, what happens to x and acceleration is that the object will cross the origin, and the acceleration is going to be positive again with some possibly different value. I will not bother solving the expression for this value, but the acceleration should be 0 in order to increase the velocity and let the object move back to the origin.